A pipe 300 meter long has a slope 1 in 100 and tapers from 1.25 meter diameter at the higher end to 625 mm diameter at the lower end. Determine the pressure at the lower end if the pressure at the higher end is 0.1 Newton per mm square and the discharge through the pipe is 100 liters per second of water. The length of the pipe given L is equal to 300 mm, convert it into meters, 0.3 meters. Then slope of the pipe 1 in 100. Diameter at the higher end, diameter of the pipe at high end, say it is D2, 1.25 meter. Diameter of pipe at lower end, D1 is equal to 625 mm. D1 is equal to 0.625 meter. See, this is the alignment of the pipe, which is lower end. Diameter at lower end D1 is equal to 0.625 meter. Diameter at higher end D2 is equal to 1.25 meter. Length of the pipe is given, which is 300 mm, that is 0.3 meter. Slope of the pipe given, 1 vertical, 100 horizontal. Let's assume this is a datum. Here datum head with respect to lower end Z1 is equal to 0, as there is no head here, but for higher end there is a head. Take it as Z2, which is equal to, see, this is 0.3 meters, this is 1 in 100, therefore 300 mm divided by 100, which is equal to 300 mm is the length, 1 in 100 is the slope. Z2 datum head is equal to 3 meters. Discharge through pipe is also given. Discharge through pipe Q is equal to 100 liters per second. We know 1 cubic meter is equal to 1000 liters. Here Q is given as 100 liters per second. 100 into 1 liter is 10 power minus 3 meter cube per second. Therefore Q is equal to 0.1 meter cube per second. Find the area of the pipe at lower end. A1 is equal to pi by 4 into D1 square. Pi by 4 into D1 is 0.625 whole square. Therefore A1 is equal to 0.306 square meter. Area of pipe at high end, A2 is equal to pi by 4 into D2 square. Pi by 4 into D2 is 1.25 meter whole square. A2 is equal to 1.227 square meter. Apply the Bernoulli's equation between the higher end and lower end. Total energy at lower end is equal to total energy at the higher end. Total energy at lower end is P1 by gamma, this is pressure head, plus velocity head, V1 square by 2G plus datum head Z1. This is the total energy at the lower end is equal to total energy at the higher end, which is equal to P2 by gamma plus V2 square by 2G plus Z2. We have to find out the pressure at the lower end. Substitute the values of gamma, V1, V2, Z1, Z2. Velocity of flow at lower end, V1 is equal to Q by A1. Therefore, V1 is equal to 0.1 is the discharge. A1 is 0.306. V1 is equal to 0.326 meter per second. Similarly, velocity of flow at high end, V2 is equal to Q by A2. 0.1 divided by 1.227. Therefore, V2 is equal to 0.081 meter per second. From the above equation, P1 by gamma is equal to mass density into acceleration due to gravity. Mass density of water is 1000 into G is 9.81 plus velocity at lower end is 0.326. V1 square is equal to 0.326 whole square divided by 2 into 9.81 plus Z1. There is no datum head at the lower end, so it is 0 is equal to P2. Pressure at higher end is 0.1 Newton per mm square. 0.1 Newton per mm square. Convert it into Newton per meter square. 0.1 divided by 10 power minus 3 whole square, that is 10 power minus 6 Newton per meter square. That is 0.1 into 10 power plus 6. This is 10 power 5. P2 is equal to 10 power 5 Newton per meter square. P2 is 10 power 5 divided by gamma. Here gamma is 1000 into 9.81 plus V2 square 0.081 square divided by 2G, 2 into 9.81 plus Z2 is equal to 300. The length of pipe is given 300 into 1 by 100, that is 3 meters. Simplifying, we get the pressure at the low end. P1 is equal to 10.19 plus 3.344 into 10 power minus 4 minus 5.416 into 10 power minus 3 plus 3. This is P1 by 9810. P1 by 9810 is equal to 13.184. Therefore, P1 is equal to 13.184 into 9810, which is equal to 129.335 into 10 cube Newton per meter square. If we want to get it in Newton per mm square, P1 is equal to 129.335 into 10 cube. 1 meter is equal to 1000 mm. Therefore, 10 power 6 Newton per mm square. Therefore, P1 is equal to 10 cube, again which is equal to 0.129 Newton per mm square. Pressure at the lower end of the pipe, P1 is equal to 0.129 Newton per mm square.